Hello and welcome to the screencast on Group 1, more commonly known as the alkali metals. I'm going to start as we start every lesson with a retrieval practice. So I want you to read through the questions, pause the video and come back when you've answered the questions. Okay, so let's see if we know the answers. What do we call the elements in Group 0? We call them the noble gases. What do we commonly call the elements in Group 1? Well, we call them the alkali metals. What do we call the elements in Group 7? They're called the halogens. What does the group number tell us about the elements in that group? It tells us how many electrons are in the outer shell, and that works for all of the groups except for Group 0. With Group 0, it just means 0 electrons are needed for the outer shell. Try to name as many Group 1 metals as you can. So starting from the top, lithium, sodium, potassium, rubidium, cesium and francium. Try to name as many Group 0 elements as you can. We've got helium, neon, argon, krypton, xenon and radon. Try to name as many Group 7 elements as you can. Starting from the top, fluorine, chlorine, bromine, iodine and astatine. Okay, so we're going to look at the properties and reactions of the Group 1 metals. We want to be able to state some of the physical and chemical properties of the Group 1 metals. We want to be able to write down some equations, word equations and symbol equations to show how the Group 1 metals react with water, with oxygen and with chlorine. And you want to be able to describe and explain how the reactivity of the Group 1 metal changes as you go down the group. So, a little recap about the periodic table. So, in the periodic table, the columns represent what we call groups. There are 8 groups, and you can see the numbers at the top of the columns. So, the one we're going to look at today is called the Group 1 metals, the alkali metals. We've got Group 2, Group 3, Group 4, Group 5, Group 6. We're going to look at Group 7 another day and also Group 0. Okay, these elements all have similar properties. So all the groups have elements with similar properties because they have the same number of electrons in the outer shell, which is sometimes called the valency shell. Okay, so here we have the 3 groups that we're going to be studying. We're going to start with Group 1, the alkali metals. Okay, so here's the names of the alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. They are the group on the furthest left of the periodic table. And you normally, when you're looking at periodic table, it will have a 1 over the group. Now, one thing they all have in common is they're all very reactive metals. And they are rarely found in nature as pure metal. So you wouldn't find a lump of sodium on the floor because it's so reactive, it would react with either the oxygen or the water in the air. So here are some of the properties, the physical properties of the alkali metals. The alkali metals are a family that make up Group 1 of the periodic table, and they share these physical properties. They're all silver-coloured metals. They're all pretty soft, and they're soft enough for us to cut with a knife, which is an unusual property for a metal. They are all good conductors of electricity and heat, like all metals are. They are shiny, but only when you first cut them. and then they go dull as they start reacting with oxygen in the air. They have a low density. So lithium, sodium and potassium are actually less dense than water, and so they will float on the top of water. Okay, so here's some of the chemical properties of the alkali metals. They're all very reactive. They all react vigorously, some even violently with water, to produce a metal hydroxide and water. They all react with oxygen to produce a metal oxide. Those formulas change as you go down the group, but in general, we have to have 2 atoms of the alkali metal and 1 atom of oxygen. Those oxides will react with water to form hydroxides. They react with chlorine to produce a metal chloride. So like sodium chloride, potassium chloride, lithium chloride. They react with nonmetals to produce an ionic compound. They all produce a metal ion with a charge of 1+. For example, Na+, K+, and lithium would have Li+. All the compounds of the alkali metals are white. So, like salt, they're all sort of crystalline white. Okay, so we want to look at some of the properties of the group 1 metals. So I'd like you to study the table, pause the video, and describe the trends in the melting point going down the group, the density going down the group, and the relative atomic mass as you go down the group. So pause the video now and come back when you've done that. Okay, welcome back. Right, so the atomic number as you go down the group increases. The density increases, so the number's getting bigger as you go down. And the melting point actually decreases as you go down the group. So that says that you have to put in more energy to melt lithium than you do to melt cesium. Okay, so what I want you to do now, we'll just have a checkpoint, and I'd like you to answer these questions and come back when you have finished them. So pause the video now and come back when you've answered the questions. Okay, welcome back. Right, let's go through the answers. So what do alkali metals look like? Well, they are silver metals that are shiny, but only when they're first cut with a knife. Why do some of the alkali metals float on water? They float on water because they have a lower density than water. Describe their reactivity with water. Right, the alkali metals react extremely vigorously or violently with water. What would you see if you added universal indicator to the water after sodium had reacted with it? Well, because you're making the metal hydroxide, which is very alkaline, what you would see is a purple colour in the water. Okay, so you're making an alkali, and that is why these are sometimes called the alkali metals. So it would turn the water purple. What products are made when potassium reacts with water? You get potassium hydroxide and hydrogen. What would you get when potassium reacts with oxygen? You get potassium oxide. What do you get when potassium reacts with chlorine? Potassium chloride. Okay, so that means we're able to state some of the physical and chemical properties of the group 1 elements. So let's move on to looking in more depth and writing equations to show how they react. Okay, so the reactions of group 1 with oxygen. So group 1 metals react with oxygen to form a metal oxide. The oxide form will depend on the group 1 metal used. So here we've got lithium plus oxygen gives you lithium oxide. Sodium reacts with oxygen to form a mixture of sodium oxide and sodium peroxide. Okay, so that's got 2 oxygens. And potassium reacts with oxygen to form a mixture of potassium peroxide and potassium superoxide. Okay, so let's look at reactions with chlorine. The group 1 metals will react vigorously when heated with chlorine gas to form the metal chloride salt. So lithium plus chlorine will give you lithium chloride. Sodium reacts with chlorine to form sodium chloride. Now you could try and write the word and symbol equations for potassium and rubidium, because as you can see they would be identical. So we would use 2 atoms of potassium. It would react with 1 molecule of chlorine and it would make 2 potassium chloride particles, like that. Okay, so we've all done this practical where we've put lithium, sodium and potassium in water. You need to know what you saw. You need to remember your observations and you have to remember them in quite a lot of detail. So we're going to just recap what we have actually observed probably a few times in science lessons. So when I put lithium with water, what I see is it floats, because we said that lithium had a density less than water. It moves around the water. Okay, you see a fizzing, there's a gas produced. Okay, and if you've got universal indicator in the water would go purple. Okay, so the products we're going to make are lithium hydroxide and hydrogen gas, and that's the gas that we see fizzing. Now when we put sodium in water, we again see the sodium floating. This time it gets so hot, it's so exothermic, that we actually see the sodium metal melting, and it goes into a little ball and it moves very fast over the water. Again we see fizzing as the hydrogen gas is made, and the water will turn purple because we're making sodium hydroxide. So the 2 products we're making, sodium hydroxide and hydrogen. Now what we see when potassium is put in water, it shows it's a lot more reactive. It floats again, melts into a ball, right? It moves on the water. We see the fizzing of the gas, the hydrogen, which has got so hot that it actually bursts into flames. And we see a lilac flame, right? Lilac shows us it's potassium. Okay, so it quickly goes into a flame that's a lilac color, and again the water turns purple as potassium hydroxide is made. So the 2 products are potassium hydroxide and hydrogen. Okay, so what I want us to do, I want you to pause the video and write the word equations for the alkali metals with water. See if you can remember them without going back. If you finish those, see if you can write a balanced symbol equation for the reaction of lithium and sodium with water. So pause the video now and come back when you've done that. Hello, right, let's go through them again now. So lithium plus water will give us lithium hydroxide plus hydrogen. Sodium and water will give us sodium hydroxide and hydrogen. And potassium and water will give us potassium hydroxide and hydrogen. Now, if you've attempted to do the balanced symbol equations, let's see how you've got on. So lithium plus water, okay, is going to make lithium hydroxide plus hydrogen. As you can see, we've got an imbalance of hydrogens. So we're going to balance it up by putting a 2 in front of the lithium hydroxide, a 2 in front of the water, and a 2 in front of the lithium. Now, in order to balance the sodium, we do exactly the same thing. So the balanced symbol equation, if you were doing potassium now, you know that that would be exactly the same. That would be 2K plus 2H2O gives you 2KOH plus H2. Okay, so we're going to do the same thing again now for the reaction of the alkali metals, sodium and lithium with oxygen. Okay, so write the word equations for the reactions between lithium and sodium and oxygen and try and do the balanced symbol equation. Pause the video now and then come back when you've completed it. Okay, so let's complete the word equations for the reaction of lithium and sodium with oxygen. Okay, so lithium plus oxygen gives us lithium oxide. Sodium plus oxygen gives us sodium oxide. I hope you've tried to do the balanced symbol equations for these reactions. So lithium plus oxygen will give us lithium oxide. Okay, so 4 lithium atoms will react with O2 to give you 2 Li2O, and 4 sodium atoms will react with O2 to give 2 Na2O. Right, we're going to do the same thing again now with chlorine. Okay, so I want you to pause the video now, attempt to do the word equations, and then, if you can, do the symbol equations for the reactions. Hello, welcome back. Right. The word equations for lithium, sodium and potassium with chlorine. So lithium plus chlorine will give you lithium chloride. Sodium plus chlorine will give you sodium chloride. And potassium and chlorine will give you potassium chloride. Right. Symbol equations for Li plus Cl2. That gives you LiCl. So we put a 2 in front of the Li and you put a 2 in front of the LiCl. I wonder if you can predict what the next one will be. Yes, exactly the same. And the same with potassium. So once you've learnt to do it, one of these equations, you should be able to do all of the ones in the group because they're all the same. Okay, so pause the video now. I want you to answer these 4 questions and come back when you've answered the questions. Okay, welcome back. Let's go through the answers now to checkpoint 2. So why do all elements in group 1 react in a similar way to each other? They react in a similar way because they all have 1 electron in their outer shell. Write a word equation for the reaction between sodium and oxygen. Sodium plus oxygen will give you sodium oxide. Write a word equation for the reaction between lithium and chlorine. Lithium plus chlorine will give you lithium chloride. And a balanced chemical equation for the reaction between lithium and chlorine gas. So 2Li, and that S in the brackets means it's a solid, plus Cl2, and the G represents the chlorine gas is chlorine is gas, and 2 LiCl. That means that we're making a solid, which is a white crystalline solid. Okay, so that is our second success criteria. So hopefully, if you've been successful writing equations, you have understood that success criteria. So let's move on to the third one. To be able to describe and explain the reactivity of the group 1 metal as you go down the group. Okay, so the group 1 reactivity, all of the metals need to lose an electron in order to get a full outer shell of electrons. So that's what they're going to do when they react. And that's how they're going to do it. We've got all of the electronic configurations on the right hand side. So as you can see, lithium is a very small atom and potassium is a lot bigger. The further the outer shell is to the positive nucleus, the weaker the electrostatic attraction. So that means the weaker the force of attraction between the negative electron and the positive nucleus is. As well as that, you have got more electrons in between the electron and the nucleus, and we call that shielding. All those electrons are getting in the way of that electrostatic attraction. So if it's further away and if there's more shielding, it's going to be easier to pull that electron away from the nucleus, like that. So potassium will lose it really easily, sodium loses it fairly easily, and lithium is a little less reactive. So it's all down to how easily they will lose an electron. So explain in terms of electrons why potassium reacts more violently than sodium. So this is the explanation. The outer electron in potassium is further from the nucleus than the outer electron in sodium, and there's one more electron shell between the electron and the positive nucleus. This means that the force of attraction between the positively charged nucleus and the negative outer electron is weaker in potassium. So the outer electron can be lost more easily in potassium. And what I want you to do is explain why sodium is more reactive than lithium. So pause the video now and come back when you've done that. Okay, so let's have a look. So sodium loses one outer electron more easily than lithium because the outer electrons, or the energy level, is further from the nucleus in sodium because we're comparing. So we use an word, or because the sodium has more shells than lithium. There's more shielding in sodium than in lithium, and because the forces of attraction to hold the outer electron are weaker in sodium. Okay, so our final task, we're going to write out the missing words in order to complete the following passage. So just jot down the missing words and then afterwards you can write the whole passage. Okay, so let's go through it. As you go down the group, the reactivity increases. Lithium is the least reactive and potassium is the most reactive. This is because the negative electron in the outer shell is further away from the positive nucleus in potassium than in lithium. It is less attracted to the positive nucleus, meaning it can be lost more easily. Okay, so that's our final success criteria, and hopefully you understand a little bit more about the properties and reactions of the group 1 metals.